Okay, everybody, we are going to do the video lecture for 7.5, chapter 7.5, so you need to be on those notes. Whoopsie. If you haven't already, I need you to go ahead and do the warm-up here. Just try your best. If you just get to it, push play and I'll explain the answers. Again, we're 7.5 notes, okay? This is the warm-up listed right there. Now, if at any point I get ahead or the video lags for some reason, just push pause, try to read through it, and then follow the explanation. Number 1 here says a compound consists of potassium and oxygen. Well, that's a metal with a nonmetal. Go find your charge for potassium. It's going to be +1. Whew. And oxygen is going to be -2. Is that balanced? No. I'm going to need at least one more potassium. Or remember, cross your charges. This is potassium oxide. Now, number 2. A sample of a compound is found to contain 6.35 grams of iron and 3.65 grams of sulfur. Express the amount of each in terms of moles. Oh, that's why I refreshed you on molar masses. Here we go. Now, first things first, take each one and you're going to build a T-chart. So this is 2 T-charts here. 6.35 grams of iron. I need to know how many moles of iron that is. And I can do that. Grams to moles, no problem. Use your green sheet. How many grams are in 1 mole? That's the atomic mass number. And you should find it's 55.85. Hopefully your handwriting's better than mine. Grams cancel. Do your division to 3 sig figs. 0.114 moles iron. I'm going to do the same thing for the sulfur. Need to figure out how many moles of sulfur this represents. Again, pause if I get ahead of you. How many grams are in 1 mole of sulfur? Use your green sheet, find the number, hit pause if you need. There are 32.07 grams of sulfur for every mole of sulfur. Cancel those out. Division will show you that in that one it's the same amount of moles. 0.114 moles. So this compound has the same amount of moles of sulfur and iron. This will help us because iron could have been iron 2 or it could have been iron 3. Sulfur's always -2. Notice the mole ratio is the same. That would indicate it's going to be FeS, one of each. Okay? We'll get to that in just a minute. Now look at these 2 formulas. What do they have in common? Look at the ratio here, 3 to 6 and 5 to 10. Well, it has, think about it, twice as many hydrogens as it does carbons. Reduce these, both of them. Reduce them. Here I can divide both numbers by 3. Here I can divide both by 5. Both times I get CH2. This simplified version is called an empirical formula. These longer versions, they're 2 different molecules or 2 different compounds actually. This is your molecular formula. Okay? Alright, I'll explain what that means in a minute. Right now we're going to worry about empirical. Empirical is the smallest ratio formula. And I'm going to show you how we can find those out. Just by knowing how much of each element is present, we can determine the formula. Those amounts can be expressed in percentages, grams, or moles. Percentages, grams, or moles. If I give it to you in percentages, that's a little daunting. That's something we don't work with. Assume that you have a 100-gram sample. This right here is what you need to be writing in, 100-gram sample of the compound. So percentages equals grams. So I say something was 35% oxygen. Well, when you start to work, you're just going to say that that's 35 grams because 35% of 100 would be 35. Okay? So whatever the percentage is, switch it to grams. From this data, whichever one I give you, the empirical formula can be determined. The empirical formula, or the simple formula, is a formula in which the elements are in their lowest whole number ratio. They're actually in their lowest whole number mole ratio. Okay? Empirical formula may or may not be the actual formula. It just depends on what compound you're looking at. Okay? If it's ionic, it will be empirical because the way we do ionic compounds is to give the lowest ratio possible. But look at glucose. Notice that's covalent, all nonmetals. Its empirical formula can be dropped down to CH2O. Divide each of these by 6. But whenever we see glucose, it shows up way bigger than this guy does, and I'll explain that next lesson. Oopsie. The subscripts represent a mole ratio. Okay, this is why we spent so much time learning moles. So no matter if I give you percentages, no matter if I give you grams or moles, your first step, step number 1, change the data to moles. Okay? If it's grams or percentages, just read it as grams and do a T-chart to change it over to moles. Okay? Step 2, I want you to write these down. Step 1 is to change everything to moles. Step 2, you're going to compare ratios. And by that, I mean divide the moles. This will make more sense in a minute. Divide all of the mole numbers by whichever is the smallest. Okay, divide all of them by the smallest. Number 3. Those numbers, whatever you get from dividing, those are your subscripts. Alright, hopefully you've got all this down. If not, push pause so you can get it. I'm about to go forward to the first 2 examples. Here's example 1. Here's example 1. Notice I'm given percentages. I'm just going to read those as grams. Because I'm going to say, no matter what you tell me, I've got 100 grams, so I'm going to have this, or 100 grams, so these percentages are just like grams. Now look, guys, you've got 3 different elements. You've got to take all 3 of those and change them to what? You've got to change those to moles. So for number 1, 32.4 grams of sodium. I've got to change that to moles of sodium. For every 1 mole of sodium, look at the atomic mass. I've got 22.99 grams of sodium. Divide. You should have 1.41 moles of sodium. Move on to sulfur. whoopsie, 22.6 grams sulfur. Every 1 mole sulfur has 32.07 grams. I really hope this lag isn't far behind by now. Divide, you'll get 0.705. Last one, 45.0 grams of oxygen. 1 mole oxygen. And guys, if for some reason this lag is really behind and this is a terrible video, I apologize again. Just, there are more videos online. Just look, determining empirical formula. Alright, I've got all my moles. I've done the first step. Now I've got to divide all 3 of these numbers by the smallest of them. Okay? Because I've at least got to have 1 mole of whatever the smallest is. And what you do to one, you have to do to the rest. So we're going to divide all of these by 0.705. Alright, so how many sodium do I have? When you divide this, you should get roughly 2. When you divide this one, you'll get roughly, well, you'll get 1. And when you divide this one, we're going for whole numbers, you'll get roughly 4. So find the formula, put it together, go metal to nonmetal, least electronegative to most electronegative. Na 2 S 1, I'm not going to write the 1, O 4. Sodium sulfate. Sodium sulfate. Now, that one wasn't that bad, right? Let's go check out the next one. Rewatch this if you need to. Remember, those numbers are your subscripts. Example 2. Compound is found to have, there we go, 4.43 grams of phosphorus and 5.72 of oxygen. Well, I've got grams, but I've still got to get that to moles. Set up 2 T-charts. And you've got to change them to moles. Okay, notice these are never going to be nice, beautiful numbers from the outset. It's just not going to happen. Excuse me. When you divide these two, you get 0.358. Divide by the smallest. Now here you got to get really good at telling decimal wise with just the smallest. Hopefully you'll see it's the top one. You got to divide all these jokers by that. So I need the ratio here. Alright, that's going to cancel. You're going to get 1 here. But down here, when I round that, I get 2.5. I mean, that's just right in the middle. It's not closer to 2 or closer to 3. So let's write this out. I have 1 phosphorus, 2.5 oxygens. Wait, what? Can you have that? Can you have 2.5 atoms of something? No. Take this whole thing and multiply by 2. Generally, that'll get you away from the 0.5s or the point whatevers. But the 2 distributes, so I'm going to have 2 phosphorus and 5 oxygens. Diphosphorus pentoxide. Because they're both nonmetals, use your prefixes. Rewatch that again if you need to. I'm going to move on. Here's 3 examples for you, okay? In one, you just have moles, so you don't even have to do any t-charts. Just divide by the smallest, and then write the formula. On 2 and 3, you've got to change those to moles, divide by the smallest, write your subscripts. Push pause now. When you push play again, I'm going to put the answers up here in a second. I'm not going to show you my work though. You've got to figure it out. The answers are K2CO3. Hopefully you tried to name these. If not, push pause again. Go give them names. Part A is potassium carbonate. B is tin 4 fluoride. And C was rough. If you got C, you're doing really good. N2O3, dinitrogen trioxide. Okay, guys, your homework for this one is homework set 7-5. Make sure you're on 7-5, okay? There are a bunch of them. Practice, 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 okay? Homework is 7-5. Good luck.